In this video, we're going to go over multiplying polynomials. In previous videos, we've gone over the basics of multiplying a monomial and a monomial, or taking each term and multiplying them together. Here are the rules for multiplying any polynomials together, whether it's binomials, trinomials, it doesn't matter how many terms it has in it. These rules will apply for any polynomial. 1. Use the distributive property. Take every term in the first set of parentheses and multiply to every term in the next set of parentheses. It doesn't matter if there's 2 terms, 3 terms, 4 terms, 5 terms. Take each term in the first set of parentheses and multiply to every term in the next set of parentheses. Once you do that, you're going to have to combine like terms. Once you combine like terms, you need to make sure the polynomial is in the correct order, standard form. Make sure the first term has the largest exponent and go descending order from that point. So let's apply these rules with this first example. I need to multiply these two binomials together. The rules tell me this: use the distributive property. That means each term in this first set of parentheses needs to be multiplied to each term in the next set of parentheses. That means I need to take this x right here and multiply it to each one of these. So let's start off with x times x. X times x gives me x to the second power because I add my exponents. Then I take this x and multiply it to 5. 5 times x, positive 5x. So I've taken this term and multiplied it to each one. Now I need to take this term and multiply it to each one of these. That means 4 times x gives me positive 4x. 4 times 5, positive 20. So I've taken each term in this set of parentheses and multiplied it to each term in this set of parentheses. Now I need to combine like terms. Nothing else has a squared, so this x squared stays the same. But this one and this one both have an x. That means I can combine those together. 5x and 4x combine together to give me 9x. And then the number or the constant stays there on the end. Let's try another example. Again, I'm going to use my distributive property. I'm going to take each term in this first set of parentheses and multiply it to each term in the next set of parentheses. That means this x needs to be multiplied to each one of those. X times x gives me x squared. X times 9 gives me positive 9x. That x has been multiplied to each one. Now this negative 3 needs to be multiplied to each one. Negative 3 times x, negative 3x. Negative 3 times 9, negative 27. And now I'll look for any like terms that I can combine together. Nothing else has a squared. These two can be combined together. 9x and negative 3x give me positive 6x. And then I put negative 27 on the end. That's the correct order. That's standard form or descending order. Next example. Again, I'm going to take each term in this set of parentheses and multiply it to each term in the next set of parentheses. I'm going to take this 2x and multiply it to each one, starting right there. 2x times 3x, 6x squared. 2x times 4, positive 8x. Now I need to take this negative 1 and multiply it to each one. Negative 1 times 3x, negative 3x. Negative 1 times 4, negative 4. And usually these middle terms are the ones that you need to combine together. 6x squared, 8x minus 3x, positive 5x minus 4. All the previous examples, when we multiply them together, we've got a trinomial. Sometimes terms cancel out, and this is going to be an example of a situation where the terms cancel out. I'm still going to go through my rules. I'm going to use the distributive property, combine like terms, make sure it's in the correct order. I'm going to take this x and multiply it to each one of these. X times x is x squared. X times negative 2, negative 2x. Then I'm going to take this 2 and multiply it to each one of these. 2 times x, positive 2x. 2 times negative 2, negative 4. When we're doing problems where it says show your work, this is what we need to see. We need to see what you're multiplying together. We need to see what you get at this point. And then we need to see what your answer is after you combine like terms. There are no other x squares. So I bring that x squared down. Negative 2x and positive 2x give me 0. 0x. There are no x's in my answer. So this one and this one cancel each other out. A negative 2x and a positive 2x cancel each other out. The only thing I'm left with is negative 4. This is what my answer for this one looks like. So sometimes terms cancel out. So let's look at another example where the terms may cancel out. Use my distributive property, combine like terms, make sure it's in standard form. That means this 2x needs to be multiplied to each one of these. 2x times 2x, 4x squared. 2x times 3, positive 6x. Now I take this negative 3 and multiply it to each one. Negative 3 times 2x, negative 6x. Negative 3 times positive 3, negative 9. There are no other x squares. 4x squared. A positive 6x and a negative 6x cancel each other out. I bring down the negative 9. Again, it doesn't matter how many terms you have. You're just simply going to take each term in the first set of parentheses and multiply it to every term in the next set of parentheses. X times x squared. Doesn't matter how many are in this next set of parentheses. I'm going to take this x right here and multiply it to each one of these. X times x squared gives me x to the third power. X times negative 3x gives me negative 3x squared. Then I take this x and multiply it to 5, positive 5x. Now I need to take this 2 and multiply it to each one of these. 2 times x squared gives me positive 2x squared. What I'm going to do is I'm going to have to combine like terms. So what I'm going to do is I'm going to go ahead and put like terms up under each other and use a vertical method here. I'm going to take this 2, multiply it to x squared, and that's the reason I'm going to put it up under this, because these need to be combined. 2 times negative 3x gives me negative 6x. And 2 times 5 gives me positive 10. I've got everything lined up that needs to be combined together, and they're in the right order. There's only one with an exponent of 3. I bring that down. I combine these together. Negative 3x squared and positive 2x squared gives me negative x squared. 5x and negative 6x give me negative x. And there's nothing to combine with that 10. It goes on the end. It doesn't matter how many terms you have. You take each term in the first set of parentheses and multiply it to each term in the next set of parentheses. Simply use the distributive property. Then combine like terms. Then make sure it's in the correct order. The next thing we need to go over are powers of polynomials. Now make sure you write the polynomial the indicated number of times. Here's the reason why. We have this rule that we've gone over, sort of a shortcut, where we can take the exponent and multiply it to the exponents on the inside of the parentheses. You have to remember that only works with a monomial. It does not work with a polynomial. I simply can't take this and square that and get the right answer. I actually have to write this out. I actually have to write this out like this. So that I can take each term in this set of parentheses and multiply it to each term in this set of parentheses. This little trick, this little rule of taking the exponent and multiplying it to the exponents on the inside only works with a monomial. It does not work with any other polynomial. It doesn't work with a binomial, trinomial, or anything else. The way you have to do these is you have to write it out twice. And the reason I wrote it out twice is because it was squared. If I had an exponent of 3, I'd have to write it out 3 times. Then I simply use the distributive property. Take that first term, multiply it to the first term in the next one. Take that x, multiply it to 5x. Take this 5, multiply it to x. And take this 5 and multiply it to 5. Combine like terms. So make sure when you have a binomial or trinomial and it's squared, you write it out twice and follow this, because you have to combine like terms. You simply can't square that and square that. It's not going to work for these binomials, trinomials, and so forth. So one more example of that. This is asking me to square this. I have to write this out twice. I have to write 2x minus 3 times 2x minus 3. And I have to take each term in this set of parentheses and multiply it to each term in this set of parentheses, starting with 2x times 2x. That gives me 4x squared. 2x times negative 3, negative 6x. Negative 3 times 2x, negative 6x. And a negative times a negative is a positive 9. I can combine those middle terms together and get negative 12x. So when a binomial is squared, write it out twice so that you can get the correct answer, because the trick of multiplying exponents together only works if this is a monomial.